B. Remember that this particular line is read as given. Uh, when you go in the final year, you have the machine learning subject, and most of the students used to implement their projects into a machine learning, and at that time they used to use this probabilistic model. And while presenting the project, most of the students used to read this as probability of A divided by B. Okay, so even though they are implementing the project, but they don't have the understanding what exactly is this. Because of that, they used to read this as probability of A divided by B. Or you can test by asking some final year students, what is this? Okay, so remember this, it is a probability of A given B. We should not do the mistake in reading this particular line. Otherwise, if you are going for the interview and read like this, they will simply reject it. So this is probability of A given B equals to probability of A and B. This can be written as probability of A and B means A intersection B. In some books, this formula can be given as probability of A and B means A intersection B divided by probability of B. Okay, so this is the formula for the conditional probability. Formula for the conditional probability. Okay, now based on that, we have solved some problems, and I had given one exercise to solve. Okay, so let us check that exercise. The back contains 3 red and 4 blue balls. 3 red and 4 blue balls. So instead of drawing the diagram, we will directly solve this. Red balls are 3, blue marbles are 4, and total are 7. Total equals to 7. 2 marbles are drawn at random without replacement. Without replacement means if you draw the first marble, the remaining marbles will be a 6. With replacement means if you draw a marble from a bag, then you again put that marble into a bag. So that is called as the replacement. So with replacement, for every experiment you will get total marbles as 7. But without replacement, for the first experiment, marbles will be 7. Then for next, it will be 6. For next, it will be 5 and so on. So the number of marbles in the bag will go on decreasing, and the probabilities will also change. If the first drawn marble is red, what is the probability of the second marble is blue? Okay. If the probability of first drawn marble is red, so what is the probability of red for the first experiment? So we will write this as a first experiment. First experiment. What is done in the first experiment? One marble is drawn, and outcome is that marble is a red. So probability of red is equals to how much? 3 by 7. Am I correct? Probability of red is 3 by 7. What is the probability of the second marble is blue? Probability of blue in the second experiment. So second experiment. Okay, so according to our formula, what is the formula? Probability of A given B is equals to probability of A and B divided by probability of B. So we have to find out this A and B. So in second experiment, what outcome we expect? Outcome we expect as a second marble is blue. So can you tell me the probability of A given B? So in second experiment, probability of blue will be equals to how much? For the second experiment, total marbles will be R will be 2 and blue will be 4, and total marbles will be 6. In the first experiment, red is 3, blue is 4, and total are 7. In second experiment, red are 2 because previous marble is a red. So red are 2 and blue are 4. Total marbles are 6. So that means it will be 4 by 6. Or we can solve this to calculate it as a 2 by 3. So probability of red and blue is equals to 3 by 7 into 2 by 3. So it is equals to 2 by 7. Is it correct? The answer is 2 by 7. Okay, so how we have calculated the answer? Because we know that in the first experiment, total bag contains all the marbles that are available, 3 red and 4 blue. And in the first experiment, they are saying that red marble is drawn. So we will calculate the probability of red. So it will be 3 by 7. For performing the second experiment, without replacement, it is saying that without replacement, that means here red marbles are 3, now those will decrease to 2, and blue marbles are 4, those will remain the same. Total marbles will change to 4 plus 2 equals to 6. So probability of picking up the blue marble out of 6 marbles is 4 divided by 6, or it is 4C1 divided by 6C1, or it is equals to 2 by 3. So just multiply these two, R and B, and get it as a 3 by 7 into 2 by 3, which is equals to 2 by 7. Now second is in second experiment we have the same, red is 3, blue is 4, total are 7. Two marbles are drawn at random without replacement. First experiment, or first experiment, this is the case. The first marble drawn is blue. So what is the probability of blue here? It will be 4 by 7. Am I correct? 4C1 divided by 7C1. So it will be 4 by 7. For second experiment. Now second experiment, red will be 3, blue will be 3. Because in the first experiment we have a blue marble. And the total will change to 6. What is the probability that second marble is also blue? Now what probability that we have to find? Probability of blue here. So it is 3 by 6 equals to 1 by 2. So probability of both blue marbles is equals to 4 by 7 into 1 by 2. 4 by 7 into 1 by 2. 2 2s are, so it is equals to 2 by 7. So probability of both blue marbles is 2 by 7. Okay, now next question. Now quickly solve this. A box contains 5 green. Green equals to 5. Yellow equals to 7. Total are 7 plus 5, 12. For the first experiment, 2 pencils are chosen at random from the box without replacement. What is the probability that they are both yellow? Okay, now can you tell me quickly, for the first experiment, probability of yellow is 7 by 12. For the second experiment, probability of yellow is, yes, what will be the probability for second experiment of picking up the yellow pencil? In first experiment, it is clear that we have total 5 green pencils, 7 yellow pencils, and total are 12. So probability of picking up yellow pencil is 7 by 12. But for second experiment, this data will change. What it will change to? Green will be same 5, yellow will be decreased by 1, that is 6, and total will change to 11. So what is the probability of picking up the yellow marble here in the second experiment? Yes?
6 by 11.
It will be 6 by 11. And probability of both yellow will be 7 by 12 into 6 by 11. Okay, now you can multiply this and calculate the answer. Okay, so let me multiply 6 ones are and 6 twos are. So this will be 7 by 22. The answer is 7 by 22. Now the last question. Two more questions like this. In Exton school, 60% of the boys play baseball. Probability of baseball is equals to 60%. Okay, so probability can be written as in the percentage, 60%, or you can write this as 60 divided by 100. Okay, so we will consider it as a 60% to avoid the calculations. And 24% of the boys play baseball and football. Probability of baseball and football is equals to 24%. Is this correct? What is written here? And 20% of the boys play baseball and football. That is, probability of baseball and football is equal to 24%. What percent of those that play baseball also play football? Now, can you tell me how this can be written? Probability of what they are asking? Probability of what percent of those that play baseball? That means we know that this event is occurred, and we have been asked to find the probability of football is equals to question mark. Okay, now you can fit this into your formula. Which formula? Probability of A given B is equals to probability of A divided by. Now, what is that formula? Let me write it quickly here. Probability of A given B is equals to probability of A and B divided by probability of B. Am I correct? Divided by probability of B. Okay, so this you can replace. A means here F and B means B. Am I correct? A means F and B means B. So this you can write it as this formula. You can convert it to. So A, that means probability of F and B. Am I correct? Divided by which term? This B. Probability of B. Okay, so do we know all the values that are required to calculate? Yes, we know all the values. So this is 24% divided by 60%. So this will become equals to,
2 by 4.
yes, how much? 6 4s are, or
2 by
12.
4.
12 2s are 24, 12 5s are 60. So it will be 2 by 5. It is equals to 2 by 5. Or if you solve this will be equals to 0.4. Or you can call this as a 40%. Am I correct? 0.4 means 40%. They have given the data in the percentage and asked the output in the percentage. So this is equals to 40%. Am I correct? 2 by 5 is equals to 0.4, and 0.4 means 40 divided by 100. 40 divided by 100 is 0.4. So 0.4 means 40 divided by 100, or 40%. Okay, so to solve this problem, what we have done, whatever the data they had given, we have written that data. So first data given is in external school, 60% of the boys play baseball. So it is probability of baseball equals to 60%. 24% of the boys play baseball and football. So baseball and football. B means baseball, F means football. So their intersection is 24%. Now, we have been asked to find out the probability of football. We have been asked to find the probability of football such that the player also plays the baseball. This sentence is written as what percent of those that play baseball. That means we know that they play baseball, and we need to find how many of them who plays baseball plays football also. So this we are writing as probability of F given B. So we have this formula of conditional probability. We'll just replace this F with A, and sorry, A with F and B with B, and rewrite the formula to calculate the final answer, that is 40%. Okay, now similar question. In external school, 40% of the girls like music. So probability of music. is equals to 40%. And 12% of girls like music and dance. 12% of girls like music and dance. 12%. What percent of those that like music also like dance? So can you write this in conditional probability term? What it should be, M given D or D given M? This is very important to find whether it is M given D or D given M. Whether I should write it as M given D or D given M. Okay, so how to find this? What they are saying, what percent of those that like music, what percent of that those that like music also like dance. So what we want to calculate? We want to calculate the people who like dance, but we know that they also like the music. So it means that D given M. Am I correct? It means that it is D given M. We have to find the probability of dance given that they like music. Okay, now just put this in the formula. Can we write formula again? Okay, so let us write a formula again. Okay, only remember this A given B, AB, AB, B. You can remember it as AB, AB, B. Okay, so what is A here? So A we have to replace with D and B we have to replace with M. Am I correct? Replace A with D and B with M. So this will be equals to, let me write here, this will be equals to probability of D given M is equals to probability of D and M divided by probability of D or M. What will be the denominator here? Probability of D or M. We are replacing B with M. B with M. So this will be probability of M. Okay, now the values we know, it is 12 and music, it is a 40%. Is it correct? D and M, and here we have written it as M and D. So whether M and D and D and M are correct, are the same? M and D, D and M, whether they are same? Intersection means common elements. So if you take it as M and D or M intersection D or D intersection M, it is going to be the same. So that's why it will not make any change. It is 12%, it is 40%. And this we can solve it to calculate as 4 3s are, 4 10s are. It will be equals to 0.3 or equals to 30%. Okay, so I hope all the numericals based on conditional probabilities that are now clear to you, so that we can move up to the next problem.